So Chapter 6, Section 4 deals with properties of rhombuses, rectangles, and squares. So first we have a rectangle, which is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. And a square is a parallelogram with 4 right angles and 4 congruent sides. So we have a rectangle, a rhombus, and a square. So first we have the rhombus corollary, which states that a quadrilateral is a rhombus if and only if it has 4 congruent sides. So remember, if and only if means that this is a biconditional, so it goes both ways. So if it has 4 congruent sides, then the quadrilateral is a rhombus. Next, we have the rectangle corollary, which states a quadrilateral is a rectangle if and only if it has 4 right angles. So if a quadrilateral has 4 right angles, then it is a rectangle. Just remember, if and only if goes both ways. Next, we have the square corollary. So quadrilateral is a square if and only if it is a rhombus and rectangle.
Like it's the combination of the two?
Yeah. So we need a square to have 4 congruent sides and 4 90-degree angles. Okay, so what do you think our shapes on the left side are in the blue circle? Rhombuses. What do you think they are on the right side?
Square.
The right side.
Rectangle, sorry.
Rectangles. And in the middle, a mix of the two of them?
Square.
A square. What are all 3 of these shapes considered?
Quadrilateral. Parallelograms.
Parallelograms. They are quadrilaterals, but the type of quadrilaterals are parallelograms.
Wait, what'd you say?
So they are quadrilaterals because they have 4 sides,
Oh, yeah.
but the type of quadrilateral is the parallelogram.
What's the difference between a parallelogram and a polygon? I know we
A polygon is like any shape that has any number of sides. So like a triangle, square, rectangle, pentagon, all of those are polygons because they have poly means multiple sides.
The parallel, what's the difference with parallel?
Remember, parallelogram, the opposite sides are parallel.
Oh, but with the polygon it's not?
Right.
Okay.
I'm not an English genius, but does rhombus sound like an each and
No.
It does.
You're so.
Rhombus.
Oh, yeah.
Okay, so now we have 3 theorems. The first one states that a parallelogram is a rhombus if and only if its diagonals are
Parallel.
Look in this picture. Do they look parallel? The diagonals. Perpendicular. Remember, this box means that they're perpendicular. So a parallelogram is a rhombus if and only if its diagonals are perpendicular. And this box means that they're perpendicular.
Oh, so that's because it made an X.
What does perpendicular mean?
90 degrees.
That they intersect at 90-degree angles. Our next theorem states that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Bisects a pair of opposite angles. So these two theorems are about rhombuses. So if it applies to a rhombus, what else does it apply to?
Rectangle.
Squares.
A square. So our main category are quadrilaterals, shapes with four sides. The sub one, parallelograms. So all these are going to be parallelograms. And then we have rhombuses, squares, and rectangles. Okay? But the characteristics of a rhombus and the characteristics of a rectangle are both characteristics of a square. But characteristics of a rhombus aren't necessarily characteristics of a rectangle. Okay, and the last one, a parallelogram is a rectangle if and only if its diagonals are congruent. Perfect. So remember, in a parallelogram, we knew that this was congruent to this, but in a rectangle, we know that all four diagonals are going to be the same length. So all four diagonals are congruent. So like this part's congruent to this one, congruent to that one, and congruent to that one. Okay, now we're going to look at some examples. Example 1, quadrilateral ABCD is a rhombus. Find the measure of each angle. So we need to find ACD. So how do we find what this angle is here?
Can you subtract 60 from 180?
Does this look like it's 180?
From 90, right?
Does this look like it's 90?
No, it looks like it's 62.
Isn't it?
And what does the other side look like?
Look, the other side is 62.
62.
Yeah.
I knew it.
I knew that.
Remember, a rhombus bisects each angle. So this angle is going to be the same as this one. So since this one's 62, this one has to be 62.
Oh, that's actually sick.
All right, now let's look at DEC next. What is this angle going to be?
62.
Kevin, what is it? 90. Because the diagonals are perpendicular to each other. So this forms a 90-degree angle.
What do you mean by perpendicular to each other?
So perpendicular means that it intersects at a 90-degree angle. So in a rhombus, the diagonals are always going to intersect at 90 degrees.
So the other side's going to be 90 degrees too? Wait, so all of them, like right there? And everything?
All the ones in the middle are going to be 90 degrees.
Oh, so I got it. It could have been time.
All right, next let's look at EDC.
38, 28.
It's 180. It's something minus 180.
180 minus
180 minus 60.
62.
It equals 180.
But that's what I said last time.
Does this angle here look like it's 118
No,
degrees?
it's 28.
So we have to do 180 minus 62 minus what else?
90.
90.
Why did you make 20?
Wait, why was minus 90?
Because, so we have a triangle here. Remember, all three angles in the triangle add up to 180.
Oh.
So we know two of them are 90 and 62. So the third one's going to be 180 minus 90 minus 62. The answer is 28.
Oh, I've been said that.
Good job, Ryan.
Singing out the random music.
Okay, last one. ABC. This angle here.
180.
No. Yes. One.
Wouldn't it be 56?
104.
This
It's
has
56.
28 as well.
Look.
The other side's 28.
Okay, so if this was
62.
if this was 28, this one is also 28. So this whole thing is 56. So we know that the opposite angle is also going to be 56.
The only reason I said
Wait,
56
wait,
was
how
not
did you
because
get 56?
Okay, so we knew that this little one was 28.
Yeah.
This part also is 28 because the diagonal bisects it. So we have 28 and 28. 28 plus 28, 56. So this whole angle here at the bottom is 56. So opposite angles are congruent. That one's 56. All right, ready for the next example? So quadrilateral MNOP is a rectangle, complete. So we need to find the measure of angle PON.
58.
So PON is what?
90.
Is it 58?
That's 90.
It's 90.
Oh, it's 90. I meant 90.
Jeremiah, does this look like it's 58?
I meant 90. I got to.
Remember, a rectangle, all four angles are going to be 90.
Is that CMO 29?
So now let's find PMO.
It's 29. No, it's not.
Yeah, it is. Isn't it?
No, because it's the other angle on the
Oh, is it 90?
Yeah, so
Oh, right.
It's 58.
No, that's 50. Yeah.
It's
Wait,
45?
No, it's not.
Isn't it 29?
Is
No,
it
I
12?
think it's 29.
Is it 90?
Is it 24?
How is it 90?
Wait, what did she say?
How is it 61?
Because 90.
Okay, so we know that this angle is 90.
Oh, you subtract. I got
So
this.
we subtract 90 minus 29, and we get 61. So this angle here is 61. So in a rectangle, remember, rectangles and rhombuses have different characteristics. So this isn't going to be the same as this one, so it's not 29. The whole thing, this whole angle is 90. So we just do 29 minus 90. 90 minus 29. So we get 61 for PMO. So now we need to find PL.
12.
12.
Wait, why is that 12?
Because it's
It's on the
congruent.
same line.
Because it's congruent.
So next we need to find MO.
58.
58.
58. Because it's the whole line. It's not half.
Yeah.
It's 24.
It's not asking for
That's
L.
24. It's 24.
Jeremiah, you're so.
So it's 24 because this
It's the
part,
whole line. If half of it is 12, the other half is 12.
this part is 12 and this part is 12. Jeremiah, if it has degrees, it's talking about the angle. But right now we're talking about the segment MO.
How can a line be 29 degrees?
Your bisecting line is 12 and 12.
Because in a rectangle, we know that this part of the diagonal, so LN is congruent to PL. ML is also going to be congruent to LN and PL and also LO. All four little things of the diagonal are congruent.
So when it has degrees, it's talking about the angle.
And when it has degrees, it's talking about the angle. We learned that in chapter 1.
Wait, fine.
So wait, how does that mean that the
So example 3, quadrilateral MORE is a square. So we know that ME is 7x minus 3 and MO is 6x. Find x.
Don't we have to equal?
Don't you have this?
Set them equal.
Isn't the other side 7x minus 3?
Shut up.
Yes, Jeremiah.
So we have 7x minus 3 is equal to 6x.
This is so easy.
Excuse me. You're going to get negative x.
What do we do to solve for x here?
Subtract by
7 by
7x.
both sides.
Subtract 7x by both sides.
6 minus 7.
So we get negative 3 is equal to negative x. So we divide by negative 1. And we get x is equal to
3.
3. Is that our answer?
Yes.
Yep.
No, it says
Yes, it says find x, not
Okay,
put it
bro.
back in.
It says find x, so x is equal to 3 is our
Can we
answer.
plug it back in to like double check it?
No.
Well, you can.
Yeah.
It's just more work.
So what's 7 times 3?
21.
21. And 21 minus 3?
17. 19.
18.
18. So ME is 18. What is 3 times 6?
18.
18. So they equal, so we know we got the right answer.
Alright. 6 times 2 is 18.
Okay, next. MT is 4x. And TE is 3x plus 2. Find OE. We set them equal first.
X equals 2.
So we subtract 3x from both sides, so we get x is equal to 2. And then what do?
You plug it back in.
We plug it in. To which one?
Both.
3x.
Right.
We plug it into the 3x.
It doesn't matter which
It doesn't
one.
matter because it's going to give us
They're
the
all
same
equal.
answer.
Shut up.
So we can plug it into 3x plus 2. So 3 times 2 plus 2. And that gives us 8. So this part is 8. So how do we find OE?
Oh, we're not done.
It's
Add
8.
8 plus 8.
8 plus 8. And what do we get?
16.
16. Because we found what TE is, which is just this diagonal, this part of the diagonal. And that part of the diagonal is going to be the same. So we just do 8 plus 8. So OE is 16. We are done.
You don't